We are always told that AI needs a lot of data to work. But here is what no one really talks about. AI systems are now generating data, massive amount of it, every single time they run. A single agent run in a RAG-based system can pull anywhere from 5,000 to 30,000 tokens of retrieved context alone, before the model has even started thinking. And then at the prompt, the tool calls, the intermediate reasoning, the model's output, and eventually the user's feedback and your evaluation score. In case you are wondering, it is not a side effect, it is the job. And this understanding of the relationship between AI systems and the data, it changes everything about how we build AI systems. You can take a pause here and think about what I just said. This is important. Very important if you are serious about building AI systems. Welcome to 𝘭𝑚𝑟𝑖𝑐. This is a channel for people who want to understand how real AI systems are built. We are neck deep in AI and we talk about everything related to it, be it infrastructure, system design, or other important ideas around AI. Today's focus is one of the most underrated ideas in AI, or rather in agentic AI, and that is data management. To drive home my point, I will compare AI systems with the traditional software systems we used to build earlier, which have shaped our thought process and system design until now. Let's start with how we have always thought about software. Traditional softwares are deterministic. Same input, same output every time. I repeat, same input, same output every time. Even if a side effect was involved, such as adding something to the database, we used to stress a lot about creating idempotent systems. If you have spent some time building software before AI era, you think of these philosophies as non-negotiable. This has a lot of advantage, and one that is relevant for our discussion today is that we didn't need to log everything. Logging was largely optional. You would capture errors, maybe key events, but only to debug failures. Because in the bulk of these cases, you could walk through the code using the sample input and understand the code's behavior with near certainty. This very basic premise has been set by AI systems. Given the same prompt to a language model twice, you will likely get two different responses. This may look like a small change, but it has huge impact on software development. If my assumption is correct, this will lead to trillions of dollars in expenditure every year across the globe in future. Though I'm not saying this non-determinism is bad, and I won't argue with you if you happen to say this is a feature, and that is not even the topic of discussion for today. What concerns me today is that this behavior forces us to log a lot of data. Because the LLM can output two different texts for the same exact prompt, we cannot predict the system's behavior given our input. And hence, to understand the final outcome from an initial input, we have to log everything in between, be it the prompt, the model output, the tool calls, or the tool outputs. You have to log everything, and that creates challenges. I would rather say data challenges. Data management is no longer a niche problem. It is a problem everyone is either facing already or will face soon. And if you are part of the 𝘭𝑚𝑟𝑖𝑐 audience, you get to know today what you are going to face tomorrow. In traditional systems, logs were optional. In AI systems, logs are the system. I'm serious. In AI systems, logs are the system. Think about what it takes to debug an AI system. When something goes wrong, and it will, you can't just look at an error log. You need to know what was the exact prompt, what context was retrieved from the knowledge base, what did the model actually output, were any tools called, or what did they return. And what did the user think of the response? And once you move from a single agent to multiple agents, it gets even harder. Now, one run can trigger another run, which calls a tool, which retrieves another piece of context, which in turn changes the final answer. Debugging that means tracing causality across whole chain, not just reading one transcript. Every one of those things is the data you have to deliberately capture, because it doesn't exist unless you build an infrastructure to collect it. And here is what makes this compounding. That same trace you captured for debugging, it is also your evaluation signal and eventually your fine-tuning data set. You are not just building a pipeline, you are building a feedback loop. And here is a pattern I have noticed. Normally, we assume startups move faster than enterprises. They ship quickly and they iterate even quicker. But in production AI, large enterprises are moving faster than people think. The reason enterprises can move this fast is that they already have what AI suddenly needs. Be it data warehouses, observability pipeline, retention policies, compliance frameworks, access control. Startups are shipping features, enterprises are building the foundations AI actually runs on. And when startups try to scale without that foundation, that is when things break in ways that are very hard to debug. And there is a cost angle here that almost no team budgets for early. Full traces, retrieved chunks, tool outputs, embeddings, eval scores, at tens of thousands of runs a day, observability stops being a dashboard and starts becoming a real line item. So what is actually changing? We are moving from system that consume data to system that generates it, from static pipelines to continuous feedback loops, from logging for debugging to logging for learning. This isn't just a technical shift, it is a design shift, and most teams aren't making it consciously. They're adding observability as an afterthought. They are discovering retention problems after the data is gone. They're trying to evaluate a system they never instrumented. The teams getting this right are the ones who decide from day one, what do we capture? How long do we keep it? Who can access it? What fits the evaluation? What should never be stored at all? And that last questions matter more than it sounds. The same data that helps you debug a model may also contain private user intents, sensitive business context, or regulated information. So the tension is real. You need enough memory, or I said data, to explain what the AI did, but not so much that your logs become the riskiest database in the company. Those aren't afterthought. They are architectural decisions, and making them late is far more expensive than making them early. The next generation of AI systems won't be won only by better models or better prompts. It will be won by teams that know how to capture, structure, evaluate, and learn from the data their AI create. Data systems are no longer just supporting your AI applications. They are becoming part of the intelligence itself. If this kind of thinking interests you, subscribe to 𝘚𝑢𝑟𝑖c. This is what we do here. We go deep and then we go even deeper. Thank you. Bye-bye.